In question 64, we're told that an inherited condition is caused by a recessive allele, and we're shown this family tree here, showing the inheritance of this recessive condition in one family. So we're given the usual notation for an inheritance diagram, with circles representing female, squares representing male, and black and white representing diseased and undiseased states respectively. Okay, so we're then told that one of the daughters in the family, represented by these circles here, has children with a man who does not have the condition. And then we're asked for the two situations described, that being the father of the new child being homozygous dominant or heterozygous. We're asked to work out the probability that the child that this daughter has will have the condition. Okay, so what we need to do first of all is work out the genotype of these two daughters. So how would we go about doing that? Well, the evidence is from the fact that this is a recessive condition, so that all individuals with the condition have a genotype homozygous recessive. Okay, but in order to achieve a homozygous recessive offspring, both parents must bear the recessive allele, since one allele is received from both parents. So, in which case, given that the mother does not have the condition, she must be heterozygous. And given that in this gene cross here, one allele has to come from both sides, so given that these do not have the condition, they must have received the dominant allele from their mother and the recessive from their father. So these are heterozygous. Okay, so we have our female offspring being heterozygous, and now we need to work out, given that the father is homozygous dominant or heterozygous, what are the chances that these will have a girl who has the condition? So we'll just work through our Punnett squares here. As you can see, if the father is homozygous dominant, which is the first scenario, none of the offspring will have the condition, and so the chance of a girl having the condition is 0. Okay, let's have a look at the situation if the father is heterozygous. As you can see, under most conditions, there is no disease state. However, 25% or 0.25 will have the condition on average. So, but that isn't quite the answer to the question, since we're asked what the chances are that a girl will be born who has the condition. So obviously we just have to multiply this by a half to work out the proportion that will be girls with the condition, since half the population is boys and girls. Okay, so we have our answer. On the left-hand side, when we have a homozygous dominant father, the chances are 0. When we have a heterozygous father, we will have a 0.125 chance of this. So we have our answer, which is B.